Hello everyone. In this video, I am trying to discuss about the charts in earthengine. These examples or sets of codes comes from the example section. In the right hand side, in the script here, we have the section called the examples. And the examples are very helpful, adaptable, and important for our purpose. And this helps us to learn and see what's and how something is being done. And these examples are really defined and very helpful. And from these sets of example today, I'm trying to discuss particularly about the charts. There are 10 sets of examples, and I will try to interpret them. The approach would be to run the examples first and then try interpreting them. So result first, then codes later. So here I'm running the first example here, and we run this and we get the histogram. So the first example is about plotting a histogram of the area. And this is the simple example, but you can see that this is important as a learning material. So we have here the elevation data. This is called Assertium digital elevation data. And here we have the area. And by using the function ui.chart.image.histogram and selecting the raster here, this is our data, and our region is this variable here, and we are creating the histogram. And by changing the value of the scale, for example, if we increase the value of this bucket white, it will be a little thinner. In this case here, it will be a little thinner. So we can play around with the values and see what's the result will bring. So this was the first example. We are generating the histogram of this area. And basically what we're doing is we are seeing the range of elevation in this area. So the lowest here is 900 in meters to 3,900 meters. And these changes based on the scale and based on the bucket white size. This can change. But for this case, the elevation is ranging from this value to this value. So this was the first example. And here we have the second set of example, and we run this again. So we run this, and here we are seeing different dotted lines being connected, and the data here is the same as in the previous one. And here we have the features, different features. These are the points with some properties, and this has been done as e.feature, and this is a feature. And here we have different features. Different features has been assigned to this variable waypoints. So, and these all the features has been converted into the feature collection by ee.feature collection, and this is now the feature collection. And by using ui.chart.image.by-region, we are drawing this chart here, and here we are. Image is the raster or the Assertium digital elevation. Our regions are the feature collection, and here we have the scale, and our X property, the name comes from the level from here, and we have used the name in each case. So this is our property, X property, and by these other options are just for the usefulness in the chart. So for example, here we have the title, vertical axis title here, and we have run this. When we run this, we are getting the dots connected by the single line. So this has been done by the ui.chart.image.by-region. We are just connecting the mean height of the different feature collection or the different points. So we can see here is the different points. And this is it. This is the second example here. Similarly, we have the third example. If we run this, so in the third example, we are seeing the two charts. First one here says Lancet TOA band values of 3 points. And second one is Lancet TOA spectra at 3 points. This is somewhere in Mexico. And here we have the Lancet TOA as our data set. And here we have the dictionary, each with different colors. These are for the locations. And similar to the previous example, we have here the feature. This is our feature, and feature is the geometry with some properties. So this is the feature one, arc. Similarly, the second one and the third one. Each one has been labeled, and this has been converted again into the feature collection. And we are bounding our data set by this feature collection. And we are using, or we are selecting the bands here from band 1 to band 7. And for the first case here, we are using ui.chart.image.regions. And this creates something like this. And this is our line chart. And here we have the title, we have the horizontal axis, we have the vertical axis here. These are important to know what the graph is about. And here we have the line height and line size. And this series here is for the color. So 3 different colors and 3 different points, or 3 different points. So, and for the second case here, we are assigning our own vertical axis. For that, we have the wavelengths, and we are assigning this as the list. So we have the different values here, but the code or the function is used is the similar as the before. Here, for example, we are using ui.chart.image.regions, and for this case also we are using ui.chart.image.regions. The difference is that we are now assigning our own x levels, and that is the wavelengths. So this time you can see here this is the x level has changed, and all the things are the same. This was the third example, and finally we have added them as the layer. These are the 3 layers. You can see these are the 3 different points. And this is our, for example, we have created the Lancet TOA band values as a line graph, and this can be done in Sentinel-2 as well. And here we have the fourth example. And here we run this again. And here we are getting the chart at the bottom right side. And when we click here, the image gets generated. So this is very nice. So here we have the area of our interest as the rectangle. And here we have the Lancet TOA filtered by date, selecting band 1 to band 7. This is the standard way of doing this. And we are creating the time series chart by ui.chart.image.series. And this is for a year. And here we have the image collection, our region of interest, or that is region. And here we are reducing it by mean, that is done by e.reduce.mean. And here we have the scale. And for the chart properties, we are positioning it to the bottom right. We have the width and height given. And here we are adding chart. And we're outlining and centering the area of the interest somewhere in the map. And that has been done by ui.map.layer. And we're adding that as layer. And similarly, we're creating the label on the map. And that level is the date here. And that date is converted every time when you click on the chart. So this is the UI.level. We are adding the level. And when the chart is clicked, it says the update the map. The map is updated and labeled. And for that, we have the chart dot on click. We have the function, and that function helps on receiving the image of that year. So here we have the image for that date. We have image here and some properties for the image display. So this function overall does the same thing as to select the image as per the clicked as per the click in the chart. So every time you click here, it's get changed. So now here we have the levels. So every time you're clicking, the new image is appearing itself. So this function will be useful in developing application, earthengine application, and so this is also useful to understand how the response works in earthengine. This is a very nice example. And similarly, we have the fifth example here. And again, we are running this. So we have here the dictionary for the colors. We have assigned the colors for different region. Here we have the city as the feature, forest and desert as the three different features. We convert them into the feature collection. And we get the Landsat 8 again. This is filtered by date. This has been filtered by date. We're selecting only the band 10. And this band 10 is converted to the Celsius. The band 10 is related to the temperature. And here we are subtracting this value. We are selecting the first and we are renaming it as the band TEMP temp. This is a way of renaming the returned value or written thing here. So we are again using ui.chart.image.series by region. We have the temps. This is the image collection. This is the variable name here. And here we have the region, 3 different regions. And we are reducing it by ee.user.mean. And this is our band here, some scale and some X property. And here we have the level. So the level comes again from the 3 different feature collection here. This is the provided levels here. And finally, we have some other things such as here, we are setting the chart type as a scatter chart. And here we have the options for the graph. And finally, we have the colors for 3 different points. Sorry, 3 different rectangles or geometries. And when we are running this, when we run this, we are getting something like this. And we have added 3 different geometries as the layer. And this appears as something like this. So we can see the desert as the highest temperature. The forest has the lowest among the 3, and city has somewhere between them. The desert has the highest. This was the example. In this example, we see the example of selecting just the single band. We are saying the function here, how to convert the temperature into Celsius. And this can be applicable to MODIS as well. This was the 5th example here. And here we have the 7th example. And this example here. So in this example here, we have the states, and here we have the temperatures. This is data set related to the temperatures, and we're selecting this one, the T mean. and we are calculating the monthly temperature per state, and this has been done by dot reduced regions. We are selecting the states, we are selecting the reducer as EE dot reducer dot mean, and here we have some scale, and we don't want to select anything that has no value. And when we run this, these are getting this one. But before that, we are not doing everything for all the months. We're selecting some months here, and that has been done by selecting the July temperature, January temperature, and something doing as subtracting them. And we are selecting the extreme states. For that, we have the coldest selected for the month of January, hottest done for the month of July, and the least variation from that, the difference between them. We also have the months. We have 4 different months here. This is January, April, July, and October. This is important for the chart here. And we are doing this all by UI.chart, feature.by property. We're selecting the states, we're selecting the months, and we're selecting the name. And when we run this, we get something like this. So this is to select only the extreme of the states. So not all the states. We're selecting only the we're only selecting some months. We're only selecting the extreme states. So this is the such case. So so as things are going somewhere here, and we're developing the function here, selecting only those months. Something we are selecting here only those months which are important for our case. So this is a very good example, and maybe much more understanding might be needed for going inside this. And we have the 7th example here. And in the 7th example, I'm going to run this again. Here we have the 3 different features again, imported into the feature collection. We're selecting the Lancet 8QA, selecting one of the band 1 to 7. And here we are doing ui.chart.image.ui series. And this, what it does is it is generating the some chart here. And the other one is ui.chart.image.ui series by year. And this is only for the band 1. And final one is ui.chart.image.ui series by region. This is for all the regions, but only the band 1 is selected. So in the last 2 charts, we only have the band 1 and band 1. This one is for the forest. This one is for all the points. So if we see here, we have 3 different charts. The first one here is generating the main band values for the year. This is for the band 1 to band 7. And the second example here is for the band 1, and the band 1 is only for the forest. So you can see this is happening for different years. And it starts from somewhere from 2013. And finally, we have the band 1, mean by day of year and region. This is for the 3 different points. So typical example can be used for our own case. We can try this for the Sentinel as well. And the ways of making the chart is very much done very simple, in a very simple way. So we are just doing the band, we're selecting the bands and drawing the line graph from that. So this was the 7th example. So now here we have the 8th example. And in this 8th example, we have the data set here of the ecoregions. And that ecoregions, from that ecoregions, we are developing, or we are drawing or generating the histogram. For that, we have ui.feature histogram. And for that, we have the here features as ecoregions here, and property as the biome name. And here we have the bucket white size, and we are setting the options. This is the title. So we are just drawing the histogram from those ecoregions biomes. So nothing much here. Maybe they might be more bit explanation, but I'm seeing here we are just drawing some histogram from that feature collection. And finally, we have the 9th example here, and we run this here. So in this example here, this is very wonderfully done because we are drawing a chart with 2 different y-axis. Here we have the average seasonal temperature Celsius, and in here we have the elevation meters, and here we have the distance here. So if we see the map here, we have the line here, and this is the line connecting 2 different points. And in this line, we are drawing, from this line, we're drawing the elevation. This elevation is of this line, and we have the change of temperature, change of the season in the years. For example, from the winter and summer in this line. So this is happening very nicely. So in this line, everything is going on. This is very wonderfully done. I think this is very helpful. So for this to go, we have 2 different points. These are the 2 different points. And from these 2 different points, the line has been drawn by dot line string. And we have selected the Landsat at GOA. For that, we have the band 10 to calculate the temperature. And this has been converted into the Celsius and renamed to temp, variable name. And here we have the summer. We are filtering date here. We are reducing it mean and doing this as renaming this as the summer. Similarly, the winter mean for the winter has been calculated. We have the elevation here, and we are adding all those bands in as a single image, and we select band values along the line, and we're shorting the points as something doing here, the starting point, and here we have the arrays, and here we have the distance slice. This is done as the work for the arrays, and by ui.chart.array.values, we have elevation and temperature, we have distance. These things are selected, and we have the chart type, and here we have the state series names. This appears in the top, elevation, winter, and summer. This appears as at the top, and we have the dot set options, and we have the vertical axis here. This is average seasonal temperature Celsius, and there are 2 different vertical axis or the y-axis. Here we have the title as elevation or meters, and for the horizontal axis we are doing distance from the point, and we have the point size, line width, And this is it. So the important thing here, going inside, is somewhere here. We're doing things with the arrays, and by doing something with arrays, this is possible here. So this is very helpful. Maybe the use case or the from this example, what we can do is maybe for understanding the changing terrain, and we can see how the how the changing terrains or how the changing geography can bring some changes in the temperature or bring a change in seasons. So for that, it can be very helpful. And finally, we have the last example. And when we run this, so here we have the states boundaries, and here we have the image collection. We are selecting tmin and tmax. This comes from this data, and we are reducing. We are reducing regions for calculating the minimum, mean, maximum, and mean temperature per state, and we are calculating the difference, maximum to minimum temperature difference per state, and setting this as a property. And we want to select the greatest difference from that. Only the top 6 has been selected. This is the way of doing or selecting the very first highest values from the resulted list or resulted from the result. And here we have the different color properties for the chart series. And finally, from UI.chart.feature.byFeature, selecting the greatest difference here. This is the variable name, and this chart has been generated. So only the 6 from the 6 different states we have drawn this. And similarly, we have the mean temperature disparity. For this, we have the here we have the UI.chart.feature.groups, and we have the temperature difference, temperature and series here. Now we are doing the scatter chart here, and for that, for this variable to do, we are doing some collections, minimum and maximum collections, and we are merging them here. And for that, we are doing a function to set some temperature and series property. So just to get this variable here, we have done so many things before that. So this was it. And in this video, I tried to quickly summarize or try to do the explanation of the charts. Maybe this was helpful, maybe this was not. If this was helpful to you, thank you for watching till the end, if you have watched it. So this much for this video. Please write any comments, or if you have better explanation or corrections in anything which I might have which I might have done something wrong while explaining them, you can correct me. So any comments are welcomed. Thank you for watching.